Good afternoon all. Now I would like to discuss about theoretical calculation on superposition theorem. See here the statement of superposition theorem is in any linear bilateral network. See here it is a linear and bilateral network, right, consisting of two or more sources. The circuit is having two sources, right. The current flowing through any branch is algebraic sum of all currents. When we consider each source separately, and the remaining sources are replaced by their ideal elements. That is, if the remaining source is voltage source, that is replaced by short circuit. Okay, if the remaining source is open circuit, so current source, that should be replaced by open circuit. Now see here we are having two voltage sources, right. Then current flowing through any branch is algebraic sum of all currents when we consider each source separately, right. First case I am considering source 1 is acting alone and calculate current. Second case I am considering source 2 is acting alone, other source is replaced by short circuit and calculate current, right. Then this total current is equals to algebraic sum of these two currents. We need to verify that one. Okay, for that purpose, first let us, for theoretical calculations purpose, let us consider two sources starting. Okay, 5 volt source and 10 volt source. Two sources are acting alone. Okay, then calculate current flowing through 2.2 kilo ohm, right. Here I need to measure current flowing through 2.2 kilo ohm, right. Here by using nodal analysis I can calculate currents, right. Let us from this circuit identify the number of junctions, right. See here one junction is present with respect to ground. At this junction all are outgoing currents I1, I2, I3, right. Apply KCL at junction V, then you will get I1 plus I2 plus I3 is equals to 0. I1 value will be V minus 5 by 1 kilo ohm, I2 value will be V minus 0 by 2.2 kilo ohm, that is V minus 0 by 2.2 kilo ohm. I3 value will be V minus 10 by 1 kilo ohm, If I take V as common, I will get V by 1 kilo. If I take V as common, I will get 1 by 1 kilo ohm plus 1 by 2.2 kilo ohm plus 1 by 1 kilo ohm, that is equals to 5 by 1 kilo ohm, 10 by 1 kilo ohm, right. If I simplify this equation, I will get 2.45 into V is equals to 15. Okay, in denominator kilo ohm and will be cancelled. Then V is equals to 15 by 2.45. I will get V value as 6.122 volts. Okay, after that current I2 is equals to V minus 0 by 2.2 kilo ohm, right. Then current I2 value is 2.7 milliamperes. This is when two sources are acting at a time. Next case 1, consider 5 volts source is acting alone and the remaining source is 10 volt source, that is replaced by short circuit. See here, this is the representation of short circuit, right. Again here I need to calculate current flowing through 2.2 kilo ohm, right. Here first case I am assuming current is represented by I1 dash, I2 dash and I3 dash. Apply KCL at junction V. I will get I1 dash plus I2 dash plus I3 dash is equals to 0, right. I1 dash value is equals to V minus 5 by 1 kilo ohm. I2 dash is equals to V minus 0 by 2.2 kilo ohm. Similarly I3 dash is equals to V minus 0 by 1 kilo ohm, right. If I simplify this equation, V by 1 kilo ohm plus V by 2.2 kilo ohm plus V by 1 kilo ohm is equals to 5 by 1 kilo ohm, that is LHS side I will get 2.45 volts is equals to 5. Then V is equals to 2.04 volts, right. Node voltage is completed, right. Then I2 dash is equals to V by 2.2 kilo ohm, right. That is I2 dash is equals to V by 2.2 kilo ohm, that is 2.04 divided by 2.2 kilo ohm is equals to 0.927 milliamperes. That is case 1. Next, what is the case 2? Case 2 here 10 volt source is acting alone and this source should be replaced by short circuit, right. Now see here case 2, 10 volt source is acting alone and the remaining source, that is 5 volt source, is replaced by short circuit. This source is replaced by short circuit here. Okay, now again apply KCL at this junction V, right. Case 2 I am indicating the currents with double dash, that is at this junction I1 double dash, I2 double dash, I3 double dash are the currents, all are outgoing currents. Then I1 double dash plus I2 double dash plus I3 double dash is equals to 0, right. After that I1 double dash value will be V minus 0 by 1 kilo ohm, I2 double dash value will be V minus 0 by 2.2 kilo ohm, I3 double dash is equals to V minus 10 by 1 kilo ohm, that is equals to 0. LHS side I will get V by 1 kilo ohm plus V by 2.2 kilo ohm plus V by 1 kilo ohm is equals to, the remaining term will be 10 by 1 kilo ohm. If I simplify this equation LHS side, I will get 2.45 V is equals to 10 volts. Then V is equals to 10 by 2.45, that is equals to 4.05 volts, right? Then current flowing through 2.2 kilo ohm is equals to I2 double dash is equals to 4.08 divided by 2.2 kilo ohm, right? That is equals to 1.85 milliamperes. Okay, according to superposition theorem, what is the conclusion? Current flowing through any branch, that is first case when we consider two sources simultaneously, current flowing through 2.2 kilo ohm is 2.7 milliamperes. That is equals to algebraic sum of all currents when we consider each source separately. First case current is I2 dash, second case current is I2 double dash, that is 1.85 plus 0.927, that is 2.77, approximate 2.72 is equals to 2.77. Hence superposition theorem is verified, right? Okay, here I calculated theoretical values for 5 volts and 10 volts, right? Similarly, you need to calculate theoretical calculations for 10 volts and 15 volts and 15 volts and 20 volts, right? Here theoretically I calculated for two sources acting simultaneously. For 5 volts and 10 volts, I can get a current value as 2.7 milliamperes. When we consider 5 volts source and second source is replaced by short circuit, I will get a current value as 0.927. If I consider primary source is act as a short circuit and secondary source is 10 volts, then current is 1.85, right? Current is 1.85, right? That is 2.7 is equals to 0.927 plus 1.85, that is 2.7 is equals to 2.7 is satisfied, right? That is for 5 volts and 10 volts is completed. Similar way, you need to calculate theoretical calculations when two sources are acting simultaneously, 10 volts and 15 volts, you will get this current value. After that, when we consider only 10 volt source is acting alone and the second source is replaced by short circuit, you will get this current value. Okay, I think this is around 2 milliamperes. Okay, after that, similarly sir, 0 volts and 15 volts, you will get 2.7, right? Then again 4.63 is equals to 2 plus 2.7, 4.7, approximately satisfied, right? Similar way for 15 volts and 20 volts also, you need to calculate total current. After that, consider 15 volt source is acting alone, then you will get this current value. After that, consider only 20 volt source is acting alone, then you will get the current value is here. Okay, after that 6.4 is equals to 2.7 plus 3.7, approximately 6.4, right? Superposition theorem is verified theoretically. Okay, in this way we have to calculate currents by using superposition theorem. Okay, thank you all.